Hello students, let me explain the concept of forced and resonant vibrations of pendulum. Okay, for that you can see there are four pendulums taken A, C, B, D. Okay, they are all connected in a single rubber string PQ. In the picture you can see the pendulum A and B are of same length and C is smallest and D is the longest pendulum. Okay, the string of the pendulum of C is very small and the D is the longest pendulum. So we want to see the forced and resonant vibration of this pendulum. Okay, so as you know, the time period of oscillation of a pendulum depends upon length. More is the length, more is the time period. That means the frequency is inversely proportional to the length. Okay, if we A and B have the same length, therefore they should vibrate with the same frequency. And this pendulum C has smaller length, it should have more frequency of oscillation, and D pendulum has larger is the longest length, therefore it should have shortest frequency. Okay, now what do? We make the pendulum A, we set it into vibrations. Okay, by displacing its path. Once the pendulum A starts vibrating, what we observe is that the pendulum B also starts vibrating with small amplitude at first. Okay, after some time it acquires the same amplitude as A. Okay, so when we set the pendulum A into vibrations, we saw that pendulum B starts vibrating with small amplitude initially. After some time it starts vibrating with the same amplitude as A. Okay, but when the amplitude of A becomes maximum, then the amplitude of B, when the amplitude of B becomes maximum, okay, when the amplitude of the B becomes maximum, then amplitude of A becomes minimum. Okay, so that because there is a sharing of energy between them, no, because of that. So initially say A is vibrating with amplitude 10 and B is vibrating with amplitude 2. Now the B is vibrating with amplitude 10, then the A will be vibrating with amplitude 2. That way it will happen because of sharing of energy. But one thing is clear is that both of them will be vibrating in the same phase. Like when the A reaches to the extreme position towards left, then B will also reach to the extreme position towards left. That's the thing. Okay, so they will become they will be in the same phase, they will vibrate in the same phase. Okay, so when the amplitude of B increases, amplitude of A decreases. When the amplitude of B decreases, amplitude of A increases. That way it will continue. Okay, so if you see the observation number 2, then the vibration of pendulum are in the same phase as I explained it again. Now this pendulum C and D also starts vibrating, but they vibrate with the very less amplitude. Okay, so now let's give the explanation for this kind of observation. When we make the pendulum A vibrates, okay, this vibration is communicated to all the pendulums B, C, D because B, C, D because they are connected to the same string PQ. Okay, now pendulum C and D are in the state of forced vibrations. Okay, while the pendulum B comes in the state of resonance. Okay, C and D have different length, so they have different natural frequency, but A and B have the same natural frequency. Because of that, the pendulum B comes into resonance. So once it comes into resonance, now A and B can exchange energy. Now A is exchanging energy B, and A is exchanging energy to B, then the pendulum B will start vibrating with the same amplitude as A. Okay, that way the amplitude of pendulum B increases. Okay, and the amplitude of pendulum A decreases, and vice versa. Again, when the amplitude of pendulum B decreases, amplitude of pendulum A increases, because there is sharing of energy between them as they are in resonance, because their natural frequency is same, because both the pendulum have the same length. Okay, I cleared all the concept over here. But other pendulums, they do not have the same length, therefore they do not comes into resonance. Okay, therefore they do not have natural frequency, they will just be on the forced vibration with very small amplitude. Understood? Okay.